All right, welcome back. We're gonna continue chapter 5. I have no idea what day lecture we're on. Anybody know? I don't really know, we're on bucket, we're on 5.2 and 5.3 day. Five point two is on the addition rule. And complements. Spelled with 2 E's, not an I. Not like you're saying something nice about the probability. And 5.3 is, I believe, on independent events. Yes. 5.3 is on independent events. Has anyone here never played Monopoly? Not the most exciting game, I actually detest the game, but it's great for examples. Everybody's played Monopoly at least once. Monopoly's a bad game because there's always a first loser. If you play right, like especially if you don't play right, you play by the house rules every family fucking uses. Where it makes the Monopoly game take fucking 5 hours instead of 1 hour. The game is really quick if you follow the rules, you don't got enough money, fuck you, you're out. That's how it is. No, that's not how people play. Like, no, I'm gonna make you grovel. Oh, you sell me your property at a discount to pay for your hotel bill. Alright, sounds like everybody's played. Let's do a Monopoly example. So a lot of people, a lot of families. Have a Monopoly house rule. Where free parking. Has like a jackpot. Every time you gotta pay a fee, you gotta pay bank fines or whatever the hell it is and all the little different things, income tax. People put it in free parking, and if you land on free parking, you get the money. Not everybody does it, but even if you don't, it is a safe spot to land. When all the houses are filled with hotels, you're like, please let me hit that cover. So here's a scenario. You wanna roll an 8. To hit free parking. Or. Roll doubles. Go directly to jail. Let's say it's your third throw. Coming up, you don't have money to pay for shit. If you get 3 doubles in a row on the third double, it doesn't matter where you landed, you immediately go to jail, you don't land there. And let's say you're broke and like, you're not paying hotel fees, you're not paying jail fees when you're in jail. So you're like, please keep me in there for 3 rounds. Maybe someone else, maybe this person will lose their have to take their houses down or some shit. So let's look at the ways we can roll an 8. We can get a 2 with a 6. We can get a 3 with a 5. You know what? I'm gonna use different colored boxes because the different dice matter. So let's say you had a green die and a red die. So you get a 2 on the green die, a 6 on the red die, a 3 on the green die, or a 5 on the red die. You could get a 4 on both dice. You could get a 5 on the green die. And 3 on the red die. Or you could get a 6 on the green die. And a 2 on the red die. You can hear that, Arturo? Pay attention to it a little bit. Other people got that haircut in this room and I didn't know shit. Yeah, much longer hair than it was like.
A little bit longer.
Yeah, it's noticeable. It's not like I took a 1/2 inch off and I expected my boyfriend or my husband to notice. How the fuck are we gonna notice you took off a 1/2 inch?
I mean, big change, you know?
Right? Gotta be something big.
Right.
So we got ways to roll 8, and then we'll do like, ways to roll doubles. Looking at the possible outcomes is one handy way of doing this, it's gonna lead us to where we're going though here. Well, I could get a 1 and a 1. In fact, I'm just gonna write them all out. Without switching pencils between each one. The green die gets a number and the red die matches it. So how many ways are there to roll an 8?
There's ways to roll an 8, there's 2 boards, and then ways to roll doubles also 2 boards.
Oh, it's a good eye, it's gonna play into what we're doing. That does count, that's why looking at it sometimes helps. How many ways are there to roll an 8? 5, I just listed it, right? 1, 2, 3, 4, 5. How many ways is there to roll doubles? 6.
On scenario, it says free parking, what does it say after?
Or
Okay, well,
roll doubles. And as an astute eye has noticed. Ways that do both. Is a green 4 with a red 4. So we'll say that's. Now you may not know this, but. Total ways to throw 2 dice. Or pair of dice. It's 36. Seems like a lot, but like. If you look at it and make a little grid out of it. We have the red die doing one thing. And the green die doing another. And there is 6 in each row. And that adds up to 36. So with that in mind, what is the probability of rolling an 8? Did anybody try 5.1 over the weekend? I hope someone tried it. It's gonna be a long fucking 2 hours. That was like, I thought we were on chapter 3. Anybody? 5 out of 36, how'd you get that? Ways to roll an 8 over the total. This is making y'all look bad. She brings me cupcakes, she fucking. She answers questions.
You paid for it, so.
I didn't pay for the third one I ate. Alright, someone else, with that in mind. What is the probability that our roll equals doubles?
six,
What?
or 6. Doubles. Sure, I'll take that.
Our chair is just stuck and throwing out numbers on the screen, I like it.
It's kind of close.
So, anybody? 6? There's 6 ways, but what's the total probability? It's gotta be a fraction.
6.
That's not a fraction,
It's
6
six out
is
of
not a
what?
fraction, 6 is
It's
a number.
number 36.
There you go, Val.
6 out of 36. Ways to get doubles. I'll say DBL. Over time.
So 36 outcomes.
Yeah, there's 36 outcomes.
Okay.
And we saw the probability. Of rolling, the roll equals an 8 or roll equals doubles. Well, if we count them up, we've got 5 here. And this would be our 6th one, our 7th one, our 8th one. We've already done the 4s, so we can't include them. Again, we don't want to include it more than once. A 9, 10, there's 10 ways. 10 ways out of 36. Now, if I had done probability that the roll equals 8 plus the probability roll equals doubles, I would have had 5 over 36 plus 6 over 36. And when you have the same denominator or same thing on bottom, you just add the numbers on top. And we would have had 11 over 36. Which is not 10 over 36. Right? So it looks like this one is 1 too high. If we did rolls plus doubles, this is 1 outcome too many. If I just add them. And what outcome is that? This one counted the 4s. And this one counted the 4s. So we double counted the 4s. 4s were double counted. Counted twice. So if I had said. Probability that the roll equals an 8. Plus the probability that the roll equals doubles. Minus the probability that the roll equals 8. And a double. We would have had 5 over 36. Plus 6 over 36. Minus 1 over 36. And we can put that all together with one denominator and we get 10 over 36. And that was the probability that the roll equals 8 or roll equals doubles. They have a shorthand notation for this. This happens all the time. Let me give you a second to finish writing that down before we go over to shorthand notation. Face on your chest, Val.
It's a locked in.
I was talking about, I'm not looking down your shirt, Val.
Oh, I thought you were
Jesus.
talking about my chest piece.
No, you got a fucking face right here.
Oh, my doctor, that I worked for a lot of years, he died of cancer.
Oh, sorry to hear that. Unless you hated him, then fuck that guy.
No, I loved him.
Okay, well, I didn't wanna like say sorry about your loss, and she's like, no, I hate that son of a bitch,
No, I love him.
you know? I asked her what she's got on her shirt, or why she's got a face on her
I
chest.
thought you
And
got
she's
my dog.
immediately pulling down her top going, no, come take a look, it's not a face. Yeah, Val,
I didn't know what you were talking about, like a face on my butt.
she's on the prowl coming into college and she's looking for those 21-year-olds.
No, yeah, that's great.
What, that cougar?
Nobody wants
Is
that.
that what we call it,
okay?
cougar?
I'm 46 and my cougar age.
Yeah,
Oh, that's sad. Thanks a lot.
cougars, that. Arturo's nodding, he's like, cougars are hot. I should probably stop before someone says, Mr. Jones is being inappropriate, even though Val's the one exposing herself. It's Val. Alright, so, we have where'd my blue pen go? Did you steal my blue pen out? There it is. Alright. So we say, the way we do is the general version of this is. Probability of event E or F. This was like my 8 or my double. We showed that it equaled the probability of the individual ones. Minus the probability of both events happening. So for 2 events, E and F. This is called the general addition rule for probability. And we say in the case of 8 and doubles. Roll equals 8. And roll equals doubles. We say these are not. Mutually. I just got to name that word. Mutually. Exclusive events. So mutually exclusive events. Also called disjoint events. Have no outcomes in common. There's no overlap. Like we had with 4, 4. That was an overlap. It showed up in both groups. So what if I had wanted, let's change our monopoly thing. New scenario. Roll a 3 or doubles. Well, the only two ways to get a 3 are a 1 and a 2. Or a 2 and a 1. So if we follow our general addition formula up there, if we call this an E and call this F. The probability of E or F. Equals the probability of getting a 3. Plus the probability of getting a double. Minus the probability of 3 and doubles. We already said doubles was 6/36. We can see that the probability of 3, there's only 2 outcomes. So 2/36 for that. Is there any overlap between what I have here for the 3s and what I have for the doubles? No, they need to pair up and they don't pair up. So that's kind of like a 0. Or 0/36. So we get 2 plus 6/36. Which is 8/36. Which is the same thing as just those two. Put a big box around that formula. That's the one you need to remember. So let's look at what happened here. Rolling a 3. And rolling doubles are disjoint events. And we saw it changed, what happened is we have probability of E or F. Equals probability of E plus probability of F. And that's all we needed, we didn't need to worry about the double count. So like the general addition rule gets simplified. Disjoint events. It's really not worth remembering that one, because if you have that one in your head and you have the other formula in your head, you're like. Fuck, which one do I use? When in doubt. Always use this one. Because this one, even if it's disjoint. If there's no overlap, that's 0 and you still get the same thing. But if you try to use this one and they're not disjoint, or if there is overlap, you're gonna get the wrong answer. If I tried to use rolling 8 or doubles here, I would have had 11/36. And that would have been the wrong answer, it would have been 10/36. So you're better off just remembering this one. A lot of textbooks and stuff teach it the other order, it was always. Always confuses me, like they think students are stupid. And gotta be like handed the easiest version first. And then upgrade to the harder version, but that really screws up people's learning. Was that fun?
Yeah.
That's right, that was fun.
So like when it comes to the homework, you gotta just implement all the numbers that you see in the homework into that. Right?
Effectively, you might have a problem like this. Example. They might say, I don't know, a bag has 10 red marbles. 6 green marbles. 2 yellow marbles. And let's go with 3 blue marbles. I'll ask some shit like, what is the probability of randomly picking a blue or green marble? Blue and green. So we can say it's the probability of picking blue. Plus the probability of picking green. Minus the probability that the marble is both blue and green. So how many marbles are there total? Is there 23? I see 10 plus 6 plus 2 plus 3. 16 plus 5 looks like 21 to me.
Yep.
You nailed it, Arturo, good job. So it looks like blue, there's 3 blue marbles out of 21. And there are 6 green marbles out of 21. And it looks like, how many marbles are both blue and green? 0. So we're gonna get 9 out of 21. Now, they may or may not take that, they may want you to simplify that. So simplifying numbers comes down to, it's always easiest to wait to simplify it till after you've got one big thing. What you do is you write out what numbers multiply to make the number on top. 3 times 3, and what numbers multiply to make the number on bottom. And if a number appears on top and bottom, you can cancel them out in pairs, replacing it with a 1. So 9 over 21 simplifies to 3 over 7. That's called simplifying fractions. Or reducing fractions. And if you want some practice with it, I have it in the Math 321 notes. I know I covered it in there. Cause this comes up a lot, or do the homework and they'll give you practice. Inevitably. What else might they do? They might throw cards at you. In a standard deck of cards. I'll say playing cards. Cause there are a lot of deck of cards these days. You got Pokemon, Yu-Gi-Oh, Magic the Gathering, there's a shitload of fucking card games. But when you say playing cards, it's implying the good old 52 cards. Does anyone ever play 52 card pickup?
Yeah, my dad did that to me.
52 card pickup is a great game, if you never played it. Has anyone ever played it besides me and Val? Alright, take a deck of cards to your parent or. Probably your dad. Your dad would love to play this with you. And say, Dad, my teacher said 52 card pickup is a great game. Will you show me how to play? I promise you, you'll have a good time. What?
I said, I don't
Have you played?
know what it is.
It's fun.
There's better games, like speed.
There are better games. Slapjack's a really fun game, especially when you're playing with a guy named Jack or John. And a standard deck of playing cards, what is the probability? Of drawing. With a single pool. Single draw. A king, queen, jack. Or heart. Oh. Upgrade, they probably won't ask you this many things, they'll just say like king or heart, but David went all out. So this is like saying probability of king or queen or jack or heart. That should equal the probability of a king plus the probability of a queen plus the probability of a jack plus the probability of a heart minus the probability of any overlaps. How many kings are in a deck of cards? 4. Out of 52. How many queens are in a deck of cards? Isn't this fun? Oh wait, someone else, someone different. How many jacks are in a deck of playing cards? 4. Let's change it up. How many hearts are in a deck of playing cards?
13.
There's 13. How many overlaps are there? Why do you say 3?
One king. And one king, queen, and jack that are.
We got the king of hearts, the queen of hearts, and the jack of hearts. Those are our overlaps. So we're gonna say minus 3 out of 52. So if I add this up, I've got 4 plus 4 plus 4 is 12, plus 13 minus 3 over 52. Is 25 minus 3 over 52 is 22 over 52. 22 is 2 times 11. What does 52 factor into? 52 is 2 times 2 times 13. I'm not gonna put x's because we're gonna use x's for other shit. I'm gonna put a little dot to represent multiplication. So only one of the 2's cancels. On top and bottom, you don't cancel out all the 2's in both spots, just one at a time. So we have 11 on top and 2 times 13 is 26 on bottom. That would be our final probability. If they ask for a decimal, that's when you turn it in and put it in the calculator. If you want in practice, you could reduce these, you're gonna get 1 over 13 for each of these. You're gonna get 1 over 4 for that one. And that one doesn't reduce. But at this point, combining, when we have different bottoms or different denominators, combining fractions is a pain in the ass. You have to get a common denominator to combine fractions. So don't reduce shit until you combine. You don't just add up the tops and add up the bottoms, I've seen that, a lot of students try to do that, it doesn't work like that. So those are the types of questions they'll ask on that. Let's talk about complements, that was also in this section. Complement. The complement of event E. It's denoted or called. E with the C floating up top like it's an X on it. Contains all outcomes. Not in E. So for like the example. The complement of. E being hearts. We would say E with a C. Means it's a diamond. Club. Or spade. That's one way of saying it. What's another way of saying the complement? What,
all other possibilities.
other than what? So like not, or not a heart. When that happens, like the probability of rolling doubles. Let's call that E. What would EC be if rolling doubles is our E? The roll is not doubles. This was 6 out of 36. Non-doubles is every other combination, when there's 30 other combinations. They add up to 36 out of 36. Which is 1. The probability of an event E plus the probability of its complement is 1. And there's a couple other ways that we could write this that become pretty useful. I could say the probability of E equals 1 minus the probability of the complement. Or I could say the probability of the complement equals 1 minus the probability of E. This gets pretty useful. In fact, I'll give you a scenario. We're not gonna calculate it yet, because you're not ready for that, you can't handle it yet, it's too much. But you'll totally be like, yeah, I can follow that. I'll give why we would wanna use this formula. Let everybody write this down.
East. Moving mountains over there. You're going fucking keys away, bro, chill.
There's no way I scoot down. I had a dog once that farted. And it was silent. So you couldn't hear it. But we know it was him, cause as soon as the smell hit everyone, he did it while he was sleeping. Woke his ass up and he fucking bolted out of the room, there was no sound or anything. It was like. And his gas hit him before it hit us. And we're like, oh fuck, the dog's fucking running, oh god. And yeah, we got a little piece of that before we were able to get out of the room, it was terrible. It's terrible. Alright, here's our scenario. I didn't ask if anyone was still writing, that was my bad. She's sitting close to her, she hasn't said a goddamn thing with her, what are you bitches about? You don't have to lie to kick it, you can say that you like it.
What?
You can say that you wish you were sitting closer and that you got a good draft of it. There's so many fun ways to do that in an elevator.
No, there isn't.
Yes, there is. There's you smell something burning? That's always a solid one. Then you gotta pick also, or you pick something people like the smell of. I smell bacon. You smell bacon or like? Is that fresh baked cookies? Everybody will. Well, not everybody reacts to the fire one. Smoke means fire and fire means danger, especially in an enclosed like elevator. You check for fire by sniffing. If you like bacon or cookies, you will like inhale for that, and you can get them good. Just let out a silent one. It doesn't work, obviously, if you had a nice little sound effect like I had, but if you're quiet, you let out, you know, a peeper. This is what happens when you get older, you don't give a fuck. Don't worry, you'll get there one day, all you young people, you'll be like, yeah, it might take till you're my age. Maybe not. But you'll be like, yeah, I can fart around with people and not care what they say. Good times. Where are they going? I waited so long to fucking go with it, oh, scenario. So let's say there are. 18 girls and 14 boys. We're gonna go with everybody being in the binary category, just to make this easier. I realize that doesn't reflect all gender breakdowns these days, but work with me if you don't like this. 18 girls and 14 boys in a club. What is the probability? Probability of selecting at least one girl if 4 people are chosen at random. So, if we're picking 4 people, how many possible outcomes could we have that? Or how many different breakdowns are related that we could have where we describe the number of girls we pick? We could have 0 girls picked. We could have 1 girl picked. We could have 2 girls picked. We could pick 3 girls. Or all 4 could be girls. What describes at least 1 girl? Which of these is at least 1 girl? What? All of them but the 0. So the probability of at least one girl. Equals the probability of one. Plus the probability of two. Plus the probability of three. Plus the probability of four. Now, the only one of these that is easy. This one is easy. These are a pain in the ass. I'll show you how to do them all. But there's another way of writing this. We could also say the probability of at least one girl. Equals one minus the probability of no girls. And it turns out. This one is easy to calculate also. Cause this one is just like, that's the probability of all boys. And no girls is the complement, this is the. The complement of that. Now let's take 10-minute break. 5.3 will be. Shorter. Rest of you that don't like books, are like, what the fuck up already about books? Books are good for you. Okay, expand your mind, keep your mind busy. I said I'd leave that up on the screen for you, and then I quickly changed it over to fucking the Goodreads thing. Did I have it up the whole time for you to do it? Okay, good. I feel like a, yeah, jackass, okay, 5.3. Independent events. If we have two events going on. Two events going on. And one doesn't affect. The probability of the other. That's a two-way thing, neither one can affect the other. We say they are independent events. This is different than disjoint events. Disjoint events is with like a single. Experiment having two different possible outcomes that have nothing in common. This is like doing two things, like rolling two dice. And that's a perfect example. Rolling two dice. Do they affect the outcome? Does one roll affect the probability of the other? Now you could argue that someone's really, you have to be phenomenally skilled at fucking throwing dice. Or you could make one die deliberately affect the outcome of the other. But in general, no, they might hit each other in the air, but they ultimately land. With a 1 in 6 chance for any die coming up. Rolling two dice are independent outcomes. For independent events. The green die doesn't affect the red die. Another thing. Drawing 2 cards from a deck. Well, this actually depends on whether or not we put the first card back after we draw. So if we replace the first card after drawing. Each draw has a 1 in 52. Chance of like. Getting the ace of hearts. And so you'll see like this topic. They'll say with replacement. This is independent. And they might say W/O or without, W/O is short for without replacement. Well, on the first card. Probability of getting the ace of hearts. There's only one of them in the entire deck, it's 1 out of 52. And if we don't replace the card, don't put it back in, and we didn't get it on the first try. And the second card would be 1 out of 51, there's now 1 less card in the deck. Which means the first draw. Affects the second draw. And we call these dependent events. Which we will explore. On Thursday, it's 5.4. And all of this falls under an umbrella category. This is all called conditional probability. Is there a condition on? What happens to affect our probability? When events E and F. Are independent. The probability of E and F. Equals the probability of E. Times the probability of F. So for example. Let's go back to our dice example. The probability of rolling snake eyes. Is actually the same thing as the probability of rolling boxcars. Does anyone know what snake eyes are on dice? 2 ones. Rolling a 1 plus a 1. What about boxcars? 2 sixes. It's like the wheels on a train. Those don't look very square. Those are shitty square sixes. Now, if you look at the list of outcomes that have it, both of these equal, there's only a single outcome out of 36 total. So 1 out of 36. Wait, I need to make sure, did I change the page too quick? Good. Let's look at this under the lens of independent events. The probability that the first die equals a 1. And the second die equals a 1. Equals the probability that the first die equals a 1. Times the probability that the second die equals a 1. On a regular 6-sided die, what is the probability of rolling a 1? 1 out of 6, there's only one outcome that has a 1 out of 6 total outcomes. The second die has the same outcome. When you multiply fractions, this is different than addition. Multiplying fractions is, bless you. Is different than addition. On addition, we left the bottom the same, we didn't touch it, we just added the or subtracted the top. Here, if I have A over B times C over D. I get A times C on top and B times D on the bottom. So we kind of like multiply tops and bottoms separately. If I do this here. This is like 1 times 1 on top and 6 times 6 on bottom. And the top is 1 and 6 times 6 is 36. So rather than like counting the actual outcomes, we can just do multiplication and find it. That's handy. This is even more handy if you're playing like poker at a casino and you're actually good at doing math quick. Like in your head quick. Because you can calculate, if you don't have it memorized, you can calculate probabilities of getting a card you need. Let's go with the game people, good chance people know. I bet that not everyone knows this one. Everybody said they played Monopoly, everybody said they used the deck of playing cards. Has anyone in here not played Yahtzee? A lot, okay, I knew this was gonna, I knew one of these was good, okay, Yahtzee. Now you played Yahtzee, how many years? Wait, I need to wait, I'm getting a little hasty here.
I'm on the last.
Those cupcakes when I get home. I might have an accident and they all fall in my mouth. No, I couldn't, I'd get sick if I ate that many cupcakes, Jesus. Alright. Wait, anyone still writing? If you are, say something, I'll leave it up. Cause Yahtzee is gonna take a while, well, maybe I can describe what Yahtzee is here first, cause the math takes a while. So Yahtzee. That's how you spell it. You get 5 dice. And a Yahtzee roll. Is getting. All 5 to match. Now, in the game of Yahtzee, you can. Pick up dice, you can roll 3 times, so you can pick up dice you don't want and keep the ones you want. And you're trying to get certain outcomes, it's a whole game. My wife plays this with her cousin a lot, I don't know why. I'll play like 1 or 2 games with them, just to like be involved. But it's not the most stimulating thing. They don't even yell fucking Yahtzee when they get a Yahtzee. I'll fucking scream, you're supposed to yell Yahtzee when you get a Yahtzee. They won't say shit, I'll be like, yeah, let's see, I'll fucking yell. And they're like, calm down, I'm like, you're not playing right. So we want to get all 5 to match, that looked like an S. Now, let's calculate the probability of getting a Yahtzee in 1 roll. In a single toss. This is gonna combine stuff we had with 5.2 and 5.3. This is good shit. This is a great example. This is not my preferred example for independent events, but it does the best. So the probability of getting a Yahtzee would be the probability of all 1s. Or all 2s. Or all 3s. Or all 4s. Or all 5s. Or all 6s. And we've seen this or before in our equations, what did or result in? It turned into adding. And then subtracting anything in common, is there anything in common with any of these outcomes? There's nothing in common, so we can say probability of 1s plus, I'm eliminating the word all here. We're gonna assume that you did it, I should put the S down low. 1s plus probability of 2s, plus probability of 3s, plus probability of 4s, plus probability of 5s, plus probability of 6s. Now, these are all identical probabilities, if I do one, I've done them all. So let's just calculate one of them. Let's do probability of all, I don't know, 5s. That is the probability that the first equals a 5. And second equals a 5. And third equals a 5. And fourth equals a 5. And fifth die equals a 5. A lot of writing, so I'm gonna pause there for a second. Hero smiles every time, he fucking likes it. You won't admit it.
What if the day you shit yourself?
That's a horrible thing to say. Why would you wish that on me?
Earlier, I thought you did.
Why would you wish that on me? That's a horrible thing to wish on
I
somebody.
don't wish. Just waiting.
But you sound hopeful.
I'm just waiting.
It's not gonna happen. I have excellent bowel control. What is wrong with you, Arturo? Now, what did we say Ann did with independent events? Turns into multiply. So this is getting tedious writing this, but I'm gonna do it just to illustrate. How this can all stack together into one giant problem that uses it up. All these ands turn into multiply. What is the probability of any given part of this? It's 1 out of 6 for each one. And we had 5 of them. Now some mathematics you may not remember, hopefully you do. When you have repeated multiplication, we can write this as 1 to the 5th power over 6 to the 5th power. Where that little number floating in the air tells you how many times they're multiplied together. This is called the exponent. And the 1 and the 6 are called the base. It represents repeated multiplication. And so that ends up being 1 times itself repeatedly is just 1. 6 times itself 5 times is actually a pretty big number. It's what? 7,776. That's a big number. That was just getting a Yahtzee of 5s. So rather than writing let's look at all the Yahtzees. Let's bring that line down, now we're gonna do this line. So probability of 1s is, I'm gonna leave it as 1 over 6 to the 5th here. Cause I don't wanna write 7,000 fucking 6 times. You having fun yet? This is the long tedious way of finding out how to get Yahtzee. There's a lot of calculations here. We can speed it up, I'll show you how to speed it up in a second. So I can add up all the numerators or the tops, and I'm gonna get a 6 on top. And we still have 6 to the 5th on bottom. As a reminder, that 6 to the 5th on bottom means this. Now, what did we say about numbers that appear on top and bottom? We can cancel them. You've got to leave behind a 1 when you do. If you don't, you might think the top is 0 when you cancel everything out. But it's not. This ends up being 1/6 to the fourth power. And what's that? Yeah, put that shit away. Let's see, I got a 1, I got a 2. 1296. That's not very likely. We wanted to see what kind of percentage that is. Let's divide that in a calculator, 1 divided by 1296. Oh, that's fun. It says this is another good learning exercise. And then it's got a little 10 with a -04, that's what my calculator says. It's scientific notation, the number up here tells you how many times to move the decimal point. If this is positive, you move the decimal point right that many times. And if it's negative, you move it left. So with 7.716, I'm gonna move it left 4 times, filling in zeros. So as a decimal, that probability is that. And as a percent, that is going to percent, we move it right twice, 0.07716%. That's a very small percent. Are you bored? She packed her shit up, fucking 15 minutes left in class. That's a good reason, cause you're gonna get in trouble, cupcakes are no. Wow, that's just insulting, packing up your shit and watching you. I think you guys will leave. So. Before Krista fucking bolts out of here like a bat out of hell. Is there an easy way to do this? There is. I ask you, does it matter what the first die is? No, why not? What does matter if that doesn't matter? If the second die, what about it? Cause the other dice have to match the first, that's all that matters. No. Just the rest of the dice need to match the first. So I can shorten this into probability that second equals first. And third equals first. And fourth equals first. And fifth equals first. And the and turns into multiplication. And if there's only one way to match each individual set of dice matches, like if the first die is a 5, I have to roll a 5 on the second die, which means there's only one match out of 6 outcomes. So we're gonna have 1 times 6. For those 4 different outcomes. And if we multiply that, we get the 1/6 to the 4th power. Or 1/1296. And rather than doing an entire page worth of fucking operations. And describing what happens, we got it down into just 3 lines. This is the idea of dependent events, which will be 5.4. Four. And we'll do that on Thursday along with 5.5. If you like Texas Hold'em or shit like that, we're gonna do a fine example with that. And if you don't like it, you don't know what you're missing. Hold'em's good shit. Other than that, you're free to GTFO. Crystal couldn't wait for 3 more minutes. Have a good evening, I will see you guys on Thursday. Unless you're going to get. As a reminder, there's no classes Friday or Monday. The 4-day weekend. I know the World Ag Fair, did it start today, or is it starting tomorrow?
I think they're.
I know some people are doing, like where they're actually going to, if you are working and have booth there, have fun.